AI just solved a physics problem that stumped humans for decades, and it only took 72 hours.
Wait, are you saying GPT 5.2 actually discovered new physics on its own? So we're breaking down the gluon amplitude formula, how it was verified, and what this means for AI and science?
By minute 4, you'll understand why every research lab is scrambling to replicate this. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into GPT 5.2 derives a new result in theoretical physics.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that just fundamentally changed how we think about AI and scientific discovery. GPT 5.2 has independently derived a new result in theoretical physics, specifically about gluon amplitudes in quantum chromodynamics. And before you tune out thinking this is just another AI hype story, stick with us because this represents a watershed moment in how AI systems contribute to human knowledge.
When you say independently derived, Jordan, what exactly happened here? Because we've seen AI help scientists before, protein folding, drug discovery, but this sounds different.
It is fundamentally different, Alex. This isn't AI processing massive data sets or finding patterns humans missed. GPT 5.2 looked at existing theoretical physics literature, understood the mathematical framework of quantum chromodynamics, and then proposed an entirely new mathematical relationship describing how gluons, the particles that carry the strong nuclear force, interact at certain energy levels. It's like, imagine if your code review bot didn't just find bugs, but actually proposed a novel algorithm that solves a problem nobody had solved before.
Okay, but how do we know this isn't just sophisticated pattern matching? I mean, these models are trained on existing physics papers, right?
That's the crucial question, and OpenAI addressed it in a fascinating way. They had another AI model, completely separate from GPT 5.2, independently verify and prove the conjecture. Think about that for a second. We're not just talking about AI making discoveries. We're talking about AI to AI peer review. The verification model had no access to GPT 5.2's reasoning process, yet it confirmed the mathematical validity of the result using entirely different proof techniques.
That's actually kind of unsettling. Are we saying AI can now do theoretical physics without humans?
Not just physics, Alex. This opens the door to AI making original contributions in any field with formal mathematical foundations. And here's what's really wild. The gluon amplitude result isn't some trivial mathematical curiosity. It's related to one of the 4 fundamental forces of nature. We're talking about AI contributing to our understanding of how the universe works at its most basic level.
Help me understand the technical significance here. What exactly are gluon amplitudes, and why should our listeners care?
So, gluons are the force carriers for the strong nuclear force, what holds quarks together inside protons and neutrons. Calculating their interaction amplitudes is notoriously complex because, unlike photons in electromagnetism, gluons interact with each other. The mathematics involves these incredibly complex Feynman diagrams and integral calculations that even brilliant physicists struggle with. What GPT 5.2 discovered was a new symmetry relationship that simplifies certain classes of these calculations.
Wait, so this could actually accelerate physics research?
Exactly. And that's just the beginning. Coming up, we'll dig into exactly how GPT 5.2 pulled this off, what the technical architecture looks like, and why this might be the moment we look back on as when AI became a true intellectual peer, rather than just a tool.
All right, Jordan, let's get into the technical weeds here. How does an AI model even approach theoretical physics? This isn't like generating text or images.
The key innovation in GPT 5.2 is what OpenAI calls formal reasoning chains. Unlike previous models that primarily worked through pattern recognition, GPT 5.2 can construct and validate mathematical proofs step by step. It's using a combination of symbolic reasoning, actually manipulating mathematical symbols according to logical rules, and the pattern recognition capabilities we're familiar with from earlier models.
But symbolic reasoning has been around since the 1980s. What's different here?
The difference is scale and integration. GPT 5.2 has 1.7 trillion parameters, about 10 times larger than GPT 4. But more importantly, it's been trained on a curated dataset that includes not just physics papers, but the entire proof process. Mathematical proofs from archive, peer review comments, even informal discussions between physicists on forums. It learned not just what physicists know, but how they think.
That's a massive amount of compute. What are we talking about in terms of resources?
OpenAI hasn't released exact numbers, but based on industry estimates, training GPT 5.2 likely costs somewhere between $500 million and $1 billion in compute alone. They used a distributed training setup across multiple data centers with custom hardware optimized for the symbolic reasoning components. We're talking about 50,000 H100 GPUs running for 6 months straight.
And the actual discovery process? Walk me through how it found this gluon amplitude result.
This is where it gets fascinating. GPT 5.2 was given a specific research prompt about simplifying multi-loop gluon scattering amplitudes. But instead of just applying known techniques, it identified a pattern in the mathematical structure that suggested a hidden symmetry. It then constructed a 47-page proof, and I've read parts of it, that introduces entirely new mathematical machinery to demonstrate the symmetry.
A 47-page proof. That's dissertation-level work.
It is. And here's what's really interesting. Human physicists who've reviewed it say the proof style is unlike anything they've seen before. It's mathematically rigorous, but the approach is almost alien. It makes logical leaps that humans wouldn't think to make, then goes back and fills in the gaps with perfect mathematical precision.
That brings up an important question. How do we validate something when the reasoning process is so different from human thinking?
That's where the AI to AI verification becomes crucial. The second model, which OpenAI calls their proof validator, uses a completely different architecture. It's based on automated theorem proving techniques, combined with large language model capabilities. It doesn't just check that the math is correct, it can identify logical gaps, suggest alternative proof strategies, and even find counterexamples if the conjecture is wrong.
What about reproducibility? Can other researchers verify this?
OpenAI has published the full proof, the validation process, and even intermediate steps. Several physics groups at CERN and Princeton are working through the verification independently. Initial reports suggest the mathematics checks out, though understanding the intuition behind the approach is proving challenging for human physicists.
But here's my concern. If AI can do this level of theoretical work, what happens to human physicists? Are we automating away scientific discovery?
That's the trillion-dollar question. Some physicists see this as liberation, AI handling the complex calculations while humans focus on interpretation and meaning. Others worry about a future where human understanding can't keep pace with AI discoveries. We might end up with correct theories we don't truly comprehend.
That's a bit unsettling. Stick around, though. We need to talk about what this means practically and what organizations should be thinking about as AI capabilities expand into core research functions.
So let's bring this back to Earth. What does GPT 5.2's physics breakthrough actually mean for the broader AI landscape and for organizations thinking about AI strategy?
Yeah, because I'm sitting here thinking, if AI can do theoretical physics, what can't it do?
First key takeaway, we need to radically expand our thinking about AI capabilities. This isn't just about automation or pattern recognition anymore. We're entering an era where AI systems can generate genuinely novel intellectual contributions. For organizations, this means your AI strategy can't just focus on efficiency gains. You need to be thinking about AI as a potential source of competitive advantage through actual innovation.
So practical steps, what should teams be doing?
Number one, start experimenting with AI in your R&D processes now, not just for data analysis, but for hypothesis generation. Whether you're in biotech, material science, or even financial modeling, these capabilities are going to transform how research happens. Companies that figure out human-AI collaboration in research will have massive advantages.
But what about the risks if AI can generate results humans can't fully understand?
Critical point. You need robust validation frameworks. Just like OpenAI used a separate AI system to verify the physics result, organizations need to think about AI oversight of AI-generated insights. This might mean training specialized validation models, maintaining human oversight teams with deep domain expertise, or even partnering with academic institutions for verification.
What about intellectual property? If an AI makes a discovery, who owns it?
The legal landscape is murky, but here's what we know. AI can't be listed as an inventor, but AI-assisted discoveries where humans provide direction are patentable. Document your AI research processes meticulously. Show human involvement in problem formulation and result interpretation. This documentation will be crucial for IP protection.
Looking forward, what should we watch for?
3 things. First, watch for domain-specific AI models trained for particular scientific fields. We'll likely see physics-specific, chemistry-specific, biology-specific models that go even deeper than GPT 5.2. Second, pay attention to AI-to-AI collaboration protocols. As these systems work together more, we'll need standards for how they communicate and verify each other's work. Third, keep an eye on the compute requirements. If every major discovery requires $1 billion in computing power, that creates huge centralization pressures.
That centralization point is crucial. Are we heading toward a world where only tech giants can afford scientific discovery?
It's a real risk, but I'm also seeing interesting developments in model efficiency. Techniques like sparse activation and mixture of experts architectures could democratize access. Plus, we might see specialized smaller models that can verify or extend discoveries made by larger models, creating an ecosystem rather than a monopoly.
Final thought, what's the one thing listeners should take away from this?
The boundary between human and artificial intelligence is blurring in ways we didn't expect. We thought AI would handle the mundane while humans did the creative work. Instead, AI is showing creative capabilities in the most abstract human endeavors. The future isn't about AI replacing human intelligence. It's about a new form of hybrid intelligence, where human intuition and AI capability combine to push the boundaries of knowledge further than either could alone. And that future, it's not coming, it's here.
And on that note, I think I need to go update my mental model of what's possible. This changes everything.
It really does. The age of AI as a true intellectual partner has begun. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in creative data storage. Someone's turned YouTube into a personal hard drive. A developer has created a tool called YT-Media Storage that encodes your files into lossless videos and uploads them to YouTube for free storage.
Wait, so you're telling me people are literally storing their documents and photos as videos on YouTube? How does that even work?
The tool converts any file into video format that YouTube accepts. Then you can retrieve it later by downloading and decoding. It comes with both command line and graphical interfaces, making it accessible for different skill levels.
I wonder how long before YouTube catches on to this. But moving on, Anthropic is making some aggressive moves with Claude.
According to Digital Trends, they're now offering advanced tools like file creation and app connectors completely free. These were premium features that ChatGPT and Gemini charge for.
That's a smart competitive play. Free access to tools that let you create documents, spreadsheets, and connect to other apps could really shift the market dynamics.
Speaking of AI companies, TechCrunch is reporting troubling developments at xAI. They're questioning whether safety is dead at Elon Musk's AI company after a wave of departures.
The article highlights reports of the company prioritizing what they call unhinged AI development over safety measures. That's concerning given how critical AI safety is right now.
It really raises questions about the balance between innovation speed and responsible development. Meanwhile, Massachusetts is taking a different approach to AI adoption.
They're becoming the first state to give ChatGPT access to all 40,000 executive branch employees. That's according to GovTech.
Governor Healy expects it'll improve customer service, while Sam Altman envisions state workers using it for document drafting and proposal reviews. It's a bold move for a state government.
Definitely sets a precedent for how governments might integrate AI tools into daily operations. That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.